Hello everyone, welcome to NPTEL classes. Here is chemistry detective to solve your chemistry class 11th NCERT problem 2.10 from your unit 2nd, that is structure of atom. Now let me make you understand what the problem is all about. Problem in fact has two parts. In part 1 we have to calculate total number of neutrons present in 7 mg of carbon, and here isotope of carbon is carbon 14. Not only total number of neutrons we need to calculate, also total mass of neutrons present in 7 milligrams of carbon 14. This is part first of this problem. In part second, it is given that electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize sodium atom. Electromagnetic radiation, when sodium atom absorbs electromagnetic radiation of wavelength 242 nanometer, it is just enough. It has enough energy to ionize sodium atom, to remove the outermost electron from sodium atom. By ionization we mean to remove outermost electron from gaseous sodium atom. And now we have to calculate ionization energy of sodium, but report our answer in kilojoule per mole. For 1 mole of sodium atoms we have to calculate ionization energy, and that too in kilojoules. Coming to part first, idea is that I need to know number of neutrons present in 1 atom of carbon 14. This will be my first work. I will calculate first number of neutrons. Number of neutrons in 1 carbon 14 atom. We know that atomic number for all isotopes of carbon is same, characteristic of carbon, that is 6. So here atomic number Z is 6, mass number A is 14, and number of neutrons is calculated by formula A minus Z, where A is mass number and Z is atomic number. For carbon 14, atomic mass number is 14 and atomic number is 6, and 14 minus 6 will come equal to 8. Now what is this? This is number of neutrons. This is number of neutrons present in 1 carbon 14 atom. Second work which I will do is that I will calculate total number of atoms present in 7 mg of carbon 14. total number of carbon 14 atoms present in its 7 mg. We know gram atomic mass of carbon 14 is 14 grams, and it is mass of its Avogadro number of carbon 14 atoms, Na. I will use this information in order to calculate number of carbon 14 atoms in its 7 mg weight. I will write 14 grams of carbon 14 contain Na carbon atoms, Na carbon 14 atoms, seven mg, which will be equal to 7 into 10 to the power minus 3 grams of carbon 14 will contain Na divided by 14 multiplied by 7 into 10 to the power minus 3, and after evaluation it comes equal to 0.5 Na. Na is Avogadro number into 10 to the power minus 3 atoms. What is this value for me? This is the number of carbon 14 atoms. This value is number of carbon 14 atoms present in its 7 mg weight. Now I know one carbon 14 atom contains 8 neutrons. Therefore, total number of neutrons in its 7 mg weight will be total number of atoms multiplied by number of neutrons in one atom. Now I will calculate here number of neutrons in 7 mg of carbon 14, and it will come equal to number of neutrons in one carbon atom, which is 8 multiplied by total number of multiplied by total number of carbon atoms in its 7 mg weight. Number of neutrons present in one carbon atom and total number of carbon atoms present in its 7 mg weight, and that is 0.5 Na into 10 to the power minus 3, and answer is equal to number of neutrons in 7 mg of carbon 14 comes equal to After evaluation, it comes equal to 2.4 into 10 to the power 21. These many number of neutrons are present in 7 mg of carbon 14. 7 milligrams of carbon 14 contains 10 to the power 21 neutrons. Now next, I have to calculate mass of these neutrons. Now I need to calculate mass of these neutrons. Mass of neutrons. Mass of neutrons present in 7 mg of carbon 14. It will be equal to mass of neutrons present in 7 mg carbon 14 will be equal to mass of one neutron, which is 1.675 into 10 to the power minus 27 kg multiplied by, this is mass of one neutron of the order of 10 raised power minus 27 kg multiplied by total number of neutrons, which is 2.4 into 10 to the power 21. This is mass of one neutron, actual mass of one neutron. This is number of neutrons present in 7 mg of 7 mg weight of carbon 14. So their product will be mass of neutrons present in 7 mg of carbon 14, and after evaluation it comes equal to, this value comes equal to 4.02 into 10 to the power minus 6 kg. This is mass of neutrons in 7 mg of carbon 14. If I have 7 mg weight of carbon 14, total number of neutrons in it will be equal to 2.4 into 10 raised power 21, and mass of these 2.4 into 10 raised power 21 neutrons will be equal to 4.02 into 10 raised power minus 6 kg. Now coming to second part of this problem. In second part of problem, wavelength of radiation is given, which is enough to ionize sodium atom. Now I need to calculate its ionization energy in kilojoule per mole. Part second. In part second, let me first write what is given. Given is wavelength is 242 nanometer. Wavelength of electromagnetic radiation whose energy is just sufficient to ionize, to remove outermost electron from sodium atom is 242 nanometer. Now I need to calculate energy, ionization energy. Ionization energy will be equal to Hc divided by lambda. This Planck's equation I need to use here in order to calculate first the ionization energy per atom of sodium. For 1 atom of sodium, I will, using this formula, I will calculate ionization energy of ionization energy. For one sodium atom, this equation after solving will give me its ionization energy. Then I need to calculate for 1 mole sodium atoms, for which I have to multiply by 6.022 into 10 raised to power 23 and then convert my answer from units of joules into kilojoules by multiplying by 10 raised to power minus 3. So first I know value, this is constant, Planck's constant, I know its value 6.626 into 10 raised to power minus 34 joules second. This is velocity of radiation light in vacuum 3 into 10 raised to power 8 meter per second. Known parameter, wavelength is given parameter, given, but I need to convert it into meters. After substituting values, first value 6.626 into 10 to the power minus 27, second 3 into 10 to the power 8, third 242 into 10 to the power minus 9 meter. Here joule second, meter per second, meter will cancel, second inverse, second will cancel, unit will be joule. And answer, after evaluating this RHS side, after evaluating these numbers, answer we get in scientific notation is 8.2 into 10 to the power minus 19 joules. This is ionization energy of one sodium atom, 8.2 into 10 raised to power minus 19. To remove outermost electron from sodium atom, this much of energy is required in joules from one sodium atom. Now I need to calculate per mole. For per mole, what I will do, I will multiply this value. In order to calculate ionization energy per mole, I will multiply this value by Avogadro number 6.022 into 10 to the power 23 multiplied by 8.2 into 10 to the power minus 19. This way I will get this energy value in terms of per mole for these Avogadro number of sodium atoms. Then I have to calculate my value from joules into kilojoules, for which I will have to multiply it by 10 raised to power minus 3 and answer I will get in kilojoule per mole. And exact answer is, after evaluating this value as well, answer is 400. Energy is ionization energy in kilojoule per mole. Ionization energy in kilojoule per mole of sodium atoms is 490 approximately. It will come 493 actual, but approximately I have made approximate calculations here, it will come 490. Therefore I can answer all the questions in sequence. First, number of neutrons present in 7 mg weight of carbon 14 is 2.4 into 10 raised to power 21. Mass of neutrons present in 7 mg of carbon 14 is 4.02 into 10 raised to power minus 6 kg, and ionization energy of sodium in kilojoule per mole is 490 kilojoules per mole. Now ideas, if I may recall, first I needed to know number of neutrons present in one carbon atom, carbon 14 atom. Then I calculated number of carbon 14 atoms present in its 7 mg weight. Then I calculated total mass, total number of neutrons in 7 mg weight of carbon. And then I calculated mass of these many number of neutrons which are present in 7 mg weight of carbon 14. And here first idea needed was how I can relate wavelength with energy, and idea it was given by Planck. I used Planck's equation not in form of E is equal to h nu but in form of E is equal to hc by lambda. Hc were known parameters, lambda was given parameter. I expressed their values in SI units and got answer 8.2 into 10 raised to power minus 19 joules. But this is ionization energy of one sodium atom. I needed to calculate for 1 mole of sodium atom. For that I multiplied this value by 6.022 into 10 raised to power 23. Then I needed to calculate answer in kilojoule per mole. As I needed to answer in kilojoule per mole, multiplying factor 10 raised to power minus 3 I introduced, and final evaluation gave me that ionization energy of sodium is 490 approximately in kilojoules per mole. Class 11 students, be blessed, follow these conceptual and numerical problems. See you day after tomorrow, as tomorrow is turn of class 12 students. Take good care of yourself, take good care of your work, which is studies, as long as you are students. Allah Hafiz.